Okay, let's take another one. This one is a trigonometry question. It's not necessarily the easiest of questions to do, but I'm going to try my best to walk it through. So let's start with the information here. The following diagram shows a triangle ABC. So we have a corner C, we have a corner B, and we have a corner A. I think technically we call them vertexes, but I don't care. So, and it tells us AC equals to 15 centimeters. Okay. It tells us that BC is equal to 10 centimeters, and that ABC, this angle here, is up there, and it's equal to some unknown quantity. Okay, and then it tells us that sine of CAB, as in not this angle, but sine of this angle. So once you take sine of this angle, I'm just going to call it A for simplicity. Once you take sine of A, your result will be square root 3 divided by 3. I want to emphasize this first and foremost because this is a very easy stumbling block to get. It's that sine, once you take sine of this angle, that's when you have square root 3 over 3. You do not have an angle here. Like, it's not that A isn't necessarily equal to square root 3 over 3. It's not that you have to put square root 3 over 3 into sine. So it's not this either. I'm just going to try and draw it so it's very clear what it's not. This right here, this is not what we have to do. What we need to do is we need to do this. We need to assume that sine of some angle that we don't know gives us square root 3 over 3. Okay, now that that's out of the way, let's actually do the work. Given that ABC is acute, as in this side here, given that it is less than 90 degrees, that's what acute means. Given that it is less than 90 degrees, find sine of theta. Figure out what sine of the unknown angle would be equal to. Please note, we don't have to ever know what this is. This doesn't matter. We only need to know what sine of that angle is equal to. That is all we need to know. So how are we going to do it? Well, what we're going to have to do here is we're going to have to use the fact that we can look at this triangle. We can go, okay, we've got here, we've got one angle with a sine that we know matching to a side. We have here an angle with a sine that we don't know that also matches to a side. That sounds an awful lot like a setup for the sine rule. So let's go ahead and use that. Yeah, it's a sine rule. Here, what we're going to do is we're going to set that up, and we're going to set it up using, I think we'll set it up with the sines on top, if you don't mind. So I'm going to write here that sine of the unknown angle. We don't know what that angle is. We only know that we need to take the sine of it. Divided by 15 should be the same as the sine of the angle A, but we know that that is square root 3 over 3. Divided by 10 should also be the same. Okay. Let's do some work now. We'll start by isolating for this, because that's what we're looking for, right? If we look up here, that's what we want to find. So all we need to do is multiply the other side with 15. We have then square root 3 divided by 3 multiplied by 15 divided by 10. Now, of course, here we can think to ourselves, well, if we divide it by 3 and then we multiply by 15, 15 is the same as 3 times 5. So what we can really write is then square root 3 multiplied by 5 divided by 10. Or if we also prefer, we can get square root 3, because 5 divided by 10 is just a half, divided by 2. And that's our answer. It is that simple. You do not need to know what the angle is. You only need to know what sine of the angle is. And once you have found it via this technique, you're done. That was question A. Okay. That's a very, very ugly check mark. There you go. So now we'll do the next one. Find cosine of 2 times CAB. Right. So now here we go. Okay. Here we're going, well, if we know that sine of A, I'm still calling it A because I find that easier. If we know that sine of A is equal to square root 3 over 3, then what should cosine of 2A be equal to? Can we figure that out? Again, notice that we're not ever being asked to figure out what A is. We do not need to know what A is. This is irrelevant, actually. We can simply use the double angle identities. And I'm going to write this down to save myself the trouble. Double angle identities. You can find these in the formula booklet. I'm just going to go by memory here, and I think that there is one that goes like this. So you have cosine 2a, or 2 theta, I think it's written as in the exam booklet. You have one that looks like this. 1 minus 2 times sine squared, as in you take the sine twice and then multiply it. Sorry, you take the sine of an angle and then multiply it with the sine of the angle. I think that this is the way that it works. Let's try and examine if it does. So we have 1 minus 2, and then we have our sine of theta is equal to square root 3 over 3. So all we need to do is take square root 3, divide by 3, and then put a squared on the whole thing. I'm going to need some more room, so I need to quickly expand this a little bit. And then we see down here that we get 1 minus 2 times, now square root 3 times square root 3. If you take the square root of 3 and you times it with the square root of 3, which is exactly what we're doing in here, you get just 3. And then below you have 3 times 3. That would then be 9. I hope that it makes sense that I'm skipping a little bit of a step here to save some time, which is that when I take the square root here and I do the square on it, I do the square on this part, and I also do the square on this part. I do them independently, so that I have 3 on top and I have 9 on the bottom. And then I see, okay, that's 1 minus 6 over 9, and that is the same then as 3 over 9, which is the same as 1/3. And that's my answer. Okay.